In today's video, we're going to look at this gargoyle, and in particular the projectile he fires, and I'm going to dive into how to create a simple but robust projectile script that will allow the projectile to calculate a trajectory based on the position to the target. Hi, my name is Michael. Join me as we build an epic Metroidvania game in Godot 4 using GD script. This is the Metroidvania Forge. All right, in a previous live stream, I had worked out this projectile system here, and I was working on showing how we could do a projectile that has kind of an arc to it like this, but you'll notice it's not hitting the player. It's not quite working how I expected. So in today's video, I'm going to cover how to build this projectile, and we're going to implement a better way to calculate the arc and discuss some of the different options. Now, obviously, if we have, let me go ahead and drop a fireball in here. If we have a fireball in the scene, I want this fireball to work in one of two ways. And you can see that I've got a horizontal only checkbox. And when we check that, I want it to just fly in a straight line. And that's fine. That's easy to do. Now, the alternative way is if I don't have that on, I want to have gravity affect it. And so I need to be able to calculate a trajectory. So like if the fireball's trying to hit the player and he's down here, based on the gravity that's going to be applied and the distance to the player, what's the vertical velocity that we need to add. Okay. Now there's a few ways that we can do something like this. So we can just do regular gravity and have it detect that time to reach the target and figure out how much vertical velocity we need. That could end up in like really fast moving, high moving projectiles, right? Because if our fireball's moving at 150 pixels per second, kind of like this, you know, a slower speed, then it's going to have to go really far up and down based on gravity to reach our target. And so I don't really want that. And one solution I thought of is allow us to control the gravity strength. Okay. And so what that would do is we could say, well, we only want maybe, in this case, it says 0.1. We only want a fraction of the gravity. So gravity is going to be really slow, which means it's only going to have to travel up and down a little bit over that time that it takes to travel to the target. Alternatively, we could give the fireball something like a max peak so that it's always going the same height. And then it just, you know, depending on the distance, it always goes up to a point and back down. We could calculate something like that. I think the downside to that solution is now we're going to have to maybe vary the gravity based on the distance or vary the speed based on the distance. And I don't really want to do either of those solutions. And so I'm going to opt for the option here that I have where we're coding the gravity strength. And so essentially what we have to do is we have to say, okay, if this fireball is going to go, you know, 300 pixels or whatever that is, then we know it's going to be traveling for 2 seconds. So how much gravity do we need, so how much vertical velocity do we need to add based on this gravity of 0.1? How much gravity do we need to add for it to go up and then be at the end of its peak, be back down and at the player's height by the time it reaches him, right? So that's kind of the math formula that we're going to be working out, okay? Because we have a few components. We've got a time, we've got a velocity based on our gravity, and so we just need to figure out, we want it to end up right here and hit the player, okay? So that's what we're going to be working on, and I'm going to review some of the code that I've already built here for this fireball, and we'll maybe write some of it from scratch so that you guys can follow along for those of you who want to do that. Okay, a couple things I'm not going to cover in this video. Let's look at the gargoyle statue. As part of this gargoyle, you can see he's got a projectile spawner. I'm going to go ahead and look at this. If you looked at the live stream, I kind of explained this code, but essentially what this does is it allows me to place it in a scene, assign a projectile as a child scene, and then what it does is we have a function here to fire the projectile, okay? And you can see what this function does. If you want to look at that, we check if we have one, and if we don't, we return. Otherwise, we take a delay into account as needed, and then we just instantiate a projectile and then call the projectile start function. And we'll be looking at the projectiles class in detail today. I've also got a fire at player function, which essentially all it does is it just calculates us a target based on the player's location. Okay, and then it just calls that same fire projectile function. So we're just using this same functionality here, but we're just assuming that our target is the player. That way we don't have to calculate a target position before we call fire projectile. And then lastly, I've got direction change code. So this is actually a pretty straightforward little script. I have it inheriting a marker 2D. That way, when it's in the scene here, I can see where it is. Okay, so this is where projectile will begin spawning. And that change direction function just helps make sure that if this enemy changes the other direction, that it moves over here. It just moves it on the X axis and not the Y. But then the projectile is what we're going to look at. And I'm going to open this up, but we're going to actually maybe rewrite all the code from scratch and just kind of start from there so that we can make this work. So I'm going to go ahead, I'm going to come to my playground, I'm going to delete this fireball, and I'm going to leave my gargoyle, and he's going to have that fireball attached. But let's go ahead and open this fireball scene. And we can see this scene in here. It consists of, it is a character body 2D. Because we're going to use the move and collide functionality that provides. We've got a sprite for the fireball. We've got an animation player that has just an animation for the fireball. It's also got a destroy animation for when it hits something. Okay. We've got a collision shape. We use this collision shape just in coordination with the character body 2D. It requires it. And you'll see how we use this to detect if we're colliding with the ground. But in addition to that, we also have a hazard area. And so this hazard area obviously is what's going to detect collision with the player and deal damage to him if we hit him. And lastly, I've got a point light just for a little bit of extra flare so that when it's zipping around the world, oh, we had one in here, you could see how it was lighting the area. Okay. So this is the scene structure that consists of this fireball. And of course, this root node, our character body 2D, has a projectile script on it. And we're going to dig into this script. I'm going to open it up and you're going to see code. But what I'm going to do is I'm going to gut it. We'll talk about it and we're going to rewrite the code. So I'll explain how the projectile works. And in the process, we'll also build two variations of it. So we'll have one variation of fireball or projectile that will fly in a horizontal line, and another one that will use some gravity, okay? And we can control how much using this gravity strength slider. And then we have just a couple other variables, obviously a move speed, and then a lifetime, so that these projectiles don't just live forever. So if you've got a really large level, you know, after 5 seconds, if it hasn't hit anything, then this projectile will just destroy itself, all right? All right, so we're looking at my projectile script here. You can see that it extends character body 2D, and I've got some variables set up, and then I've just got placeholder functions. Okay, so we're going to go over these one by one, but I haven't removed, I'm not going to write all this, but essentially we've got our export variables, checkbox if it's horizontal only, a movement speed, a lifetime. I've exported a range for my gravity strength, so from 0 to 2 at intervals of 0.5, 0.05. That gives us this nice slider that as you drag it, it kind of, you know, sticks to those types of values. And then I've got a category for audio, a spawn, and a destroy audio stream. And you can see I've got those assigned here. And then I've got a few other variables. Now, this is where I might typically have some on-ready variables, but I just don't know what the composition of any particular particle scene is going to be. And so I'm defining a few things. I've got gravity set as 980. And let me talk about that real quick, actually. We have that set in our project settings. We could grab it from there. In the past, I've used get gravity. Get gravity works, but it doesn't work on the initial frame when we create a node because it's going to be 0 because no gravity has been applied to the body yet. And so for that reason, I just chose to store it here. And then we, of course, multiply it based off of our gravity strength. But the target position, this is obviously where we're trying to hit. We've got an animation player, an attack area, and a sprite 2D. These are the 3 nodes that I would probably have on ready variables in other setups. But in this case, we're just going to handle them only if we have them. Okay. Now, as we look further into this script, you can see I've got a ready function. I'm using the physics process. I have a start method or function, a lifetime timer, on damage dealt, and destroy functions. And we're going to flesh each of those out in turn as we go through the code. But of course, it makes sense that we begin here with our ready function and talk about what this needs to do. Now, because I've got some things up here like our sprite, attack area, and animation player, and I don't yet have reference to them, the ready function is where I'm going to check to see if they exist on my current projectile. And if they do, we'll grab a reference and we'll store them here. And if we don't, if those are null, right? If these are null, then we'll know that we don't need to do anything with them later in our code. So we'll just start by looping over our children. So for C and get children, we can check each of these and see if they fit any of the criteria or the node types listed above. So we'll just start if C is attack area. Okay, now I'm saying attack area. Our hazard area is a script that extends attack area, so that will check out as an attack area, right? Okay, so this will catch the hazard area. Alternatively, if you did add an attack area, like your projectile only activates at certain time with an attack area, then that would work as well. The only difference between attack area and hazard area in my code is that the hazard area is always on, whereas an attack area you have to enable temporarily when an attack is happening. Okay, so if we have an attack area, then we'll store it just like that. And then also I want to, in case it is a regular attack area and not a hazard area, we can say attack area dot, and then we have a set active method that we can call. Okay, and by default that sets it active to true, so we don't need to pass in any arguments there. And then lastly, with this attack area, what we want to have happen is when this fireball hits a player, I'm already on the destroy animation, we want to have it destroy itself and maybe play this animation. Okay, so in our script, we're going to connect to the attack area's damage dealt signal. So we'll say attack area dot damage dealt dot connect. And we already created that function below in my script. It's called on damage dealt. So we'll just connect that function to this signal. And there we go. Our attack area is configured. And if you don't have one, then the projectile is pretty much just a visual item, right? It's not going to deal damage to the player. Now, next, I'm going to check if we have an animation player. So LFC is animation player. There we go. Then I'm just going to assign it. And that's it. That's all we have to do for an animation player. And we have one other check we need to do. We need to look for our sprite 2D to see if we have one. So we'll say elif C is sprite 2D. Then we'll assign the sprite, and we'll also flip it if we need to. So I'm going to say if velocity.x is less than 0, and then we'll just come down here and we'll say sprite.fliph equals true. True. All right. There we go. So this is the setup that we need to grab those nodes and do any basic things. Now, technically, I think this is actually not super needed because we'll have a change direction set up below. But this will be a handy way to make sure that we're dealing with that. And then the last thing I want to do in here is we have that timer. So up here you can see we've got, where is it? Lifetime. That's what I meant by timer, I guess. We've got this lifetime variable. I want to set up a function that handles the timing of that. And we'll go in and code the function. But for now, I'm just going to call it on my ready function so that we initialize it. And it's a lifetime timer. That's the function I have written below. You could call it start timer or something like that. But there we go. Our ready function is now complete. And if we run our project, I've got a gargoyle. He's going to spawn one of these and probably nothing will happen. Yeah, it just created it right there. And you can see it's going to get brighter and brighter because every time he attacks, it's going to create an additional fireball. The fireball is not doing anything, but it is spawning. Okay, and it can hurt the player because I've obviously got that hazard area attached. I'm going to go ahead and decrease the damage of this so that we can test it without dying. We just got to make sure we come back and set that again. There we go. Okay, now the next thing I want to do is I'm going to skip our physics process and our start functions. Okay, I want to look at these other small ones down below and let's just set these up to work. So this lifetime timer function, all it really needs to do is create a timer and then respond when the timer ends. That's the sole purpose of this. And I'm going to do this in 2 lines of code. And so what we're going to do is we're going to use an await, and we're going to use the getTree create timer function. And then in here, what we'll do is we'll just pass in whatever that lifetime value is. That will be the duration of this timer. And of course, since this is an await, we're awaiting the timeout signal of this timer. Okay. So essentially this function gets called when the node is ready, as soon as it's created, and then it instantly just waits for a timer to happen. So this becomes an asynchronous function. And as soon as that timer ends, it will call the second line of code here that we provide. And we're going to just call the destroy function. Okay. So we've got a destroy function down here that we're going to call. That's all it's going to do. It's going to say, okay, after a certain amount of time, destroy yourself. And before we do the destroy function though, let's look at this on damage dealt. because it's going to do something similar. Instead of waiting for a timeout, what damage dealt is going to do is it's going to say, okay, did we deal damage? Okay, if we did, then let's go ahead and destroy ourselves. And I'm going to use destroy.call deferred. I think this is necessary. And what call deferred does is it just says, call this at the end of the frame. This is usually needed when we're doing things like manipulating physics objects in response to a signal, because of the time that signals happen in the life cycle of a frame. I don't know if this is 100% necessary, but I feel like we should do this. Otherwise, if you just just destroy like this, you might get some sort of warning or error. Okay, so we're going to call it deferred. It'll still call that frame just at the very end. So now that we've got two different functions calling our destroy function, it's time to go ahead and code this up. Now, the destroy function is pretty straightforward. And what I'm going to do is, if the projectile needs to be destroyed, I'm going to do a couple things. One, I'm going to assume that it's not moving anymore. Okay. And so first we'll set our velocity to 0, which will come into play once our physics process is working. So we'll just say velocity equals, and we'll just do vector2.0. Now, you don't have to do this. You could let it continue to move, or maybe you make it move in a different direction, so you set a different velocity. But I just want it, the fireball hits a wall, it's just going to stay there and explode. Or if it hits the player or another object, it'll just stay in place, okay, and explode. In addition to this, though, I guess we should set our gravity strength. I'm going to set our gravity strength to 0. That will prevent it from falling, okay? So that, because our gravity is going to constantly be adjusting the velocity, but we're using this gravity strength to multiply the gravity that will apply. And again, we haven't done this yet. It will be in our physics process, but so we'll just set that to 0. And there we go. So we've done that. So then there's a couple things that we want to do. We've got an audio that we can play back when we hit something, a destroy audio that we've included. In fact, if we just refresh our memory, right here, destroy audio. So we're going to want to play that. We also have an animation on our animation player that we're going to want to play back, okay, if we have an animation player. And then lastly, we need to queue free this node. So let's go down here to our function again, and we'll start with our audio. So if we have destroy audio, then we can play it back. And I'm going to use our global audio script to handle this. So I'm going to say audio.play spatial sound. And then we'll just pass in the destroy audio. And we need to provide a position here as well. So we're just going to grab this node's global position. That's where the audio source will play back from. There we go. And then this, of course, uses that audio pooling system that we've built for our 2D audio. Nice and handy. Actually, one thing I missed as I was going through this, if we've got an attack area, we should disable it so that while it's playing back the explosion or destroy animation, you can't take damage a second time. So if we have an attack area, let's do that. If attack area, then we'll say attack area dot, and then we'll use that same set active function, but this time we'll pass in false. So it'll disable the attack area. And now, lastly, we can play back the animation if we have an animation player. So this is kind of more of this defensive coding that we've talked about more in recent videos, but essentially these are bits of functionality that will happen if we have the required components, otherwise they won't. And it allows us to use this script in a very modular way. And if you create some sort of like an arrow that you don't want to destroy animation, it's just going to disappear when it hits the player, then you don't have to add a destroy animation and it will still work, okay? And so we'll say if animation player, and then we also need to check if our animation player has a destroy animation, because we don't know that for sure. Okay, so just check if it has animation destroy. You just pass in the string name of the animation that you want to play back, right? So here naming becomes quite important. If we do have it, then we'll just play it. And then the other thing we want to do, because our last line here is going to be to queue free the node. Not queue redraw, but queue free. And so if we want to see that animation, we don't want to queue free instantly, or we're not going to see it play back. So what we can do is if we played the animation, then we'll await the animation as well. Now, in order for this to work, you have to make sure that this animation is not looping, because a looping never gets an animation finished signal. So just an important little note there. Okay, so now this should kind of work. And in fact, I mean, let's go ahead and run the game. right now the fireball doesn't move, but I should be able to hit it. It plays the destroy audio and animation, and then it Q frees it. Okay, so it's working even though the fireball doesn't move. It is giving us, we can see that all the code we've just hooked up is working as expected. Okay, now we do need to do two more functions. We've got our physics process and our start function. And let's go ahead and add the physics process code. It's not going to work fully right away because we aren't really assigning a velocity to this fireball. We're going to do that in the start or to this projectile. Okay, but we'll go ahead and begin by building the physics process so that we can slowly start adding in our velocity and trajectory type code. So physics process is going to be very simple. We just need to move the projectile based on whatever velocity it has. We also need to be detecting collisions. And then lastly, we want to apply gravity. And actually, we kind of said that in a weird order because we'll apply gravity first. So let's go ahead and just modify our velocity.y. And we'll just use plus equals. And then we're going to say gravity times we've got our gravity multiplier or gravity strength. And we also need to multiply this by the delta. Okay, so that it moves appropriately for the amount of time that's passed. And that's going to increase our velocity on the y-axis by the gravity over time. Now, the next step is to move it. And normally we would do something like move and slide. We've done that a lot with our character bodies. But with this one, we're going to use move and collide. Okay, now let's go ahead and look at this real quick. The difference between move and slide and move and collide is that I don't see move and slide. Where is it at? Here's move and collide, obviously, because I clicked on that. But let's go back. Let me type in move and slide. I love the documentation in Godot, by the way. Move and slide moves the body based on velocity. If it collides with another, it will slide along the other body rather than stop immediately. If the other body is a character body 2D or rigid body 2D, it will also affect or be affected by the motion of the other body. And there's some more information there. But so you see that what this is saying is that when we have a collision, we slide. This is really good for our player. Obviously, it allows us to have gravity onto the floor, move him in a direction, and he just kind of slides along the floor, and it gives us that nice movement quality that we want for a typical platformer. But what we want for this is move and collide, and you'll notice I'm getting an error, and we'll address this momentarily here. Move and collide moves along the vector of motion. In order for the frame rate, we don't need to worry about that. It returns a kinematic collision 2D, which contains information about the collision when stopped or when touching another body along the motion. So this is good for what we want it for. Now, really, you could use move and slide, and it would work just fine. And the reason I've done this is in my testing, I had a lot of issues with my hazard area detecting collision with the ground, even if I flagged it to detect collision with the ground, or with tile maps in particular. And there were ways to fix this, but it required going to all tile maps and flagging something, and I just didn't like that solution. So the alternative solution I landed on was using move and collide, because this does detect collision with our tile map without any issue. And what I'm talking about is our character body has no issue detecting collision with tile maps. This hazard area, because it's an area, it does. Okay, and you'll notice if we go back to our script, the ways that we have to destroy items are based on the hazard area collision or the timer, right? And so it's like, hey, if the hazard area is not detecting collision with the wall, then our fireball, our projectile will just go through the wall. We really don't want that. So you'll notice move and collide requires us to pass in some arguments. We've got the motion that we want to move along. There's some other values that we're not really going to use, like test only, and you can see if it's true, it doesn't move, but the would-be collision information is given. That's kind of interesting, so you can use it to detect collision even if you're not moving, and some other things, okay? But really, all we need to provide is this first motion. It's the only required argument. So if we go back to our projectile, we can come in here, and we can just pass in our velocity. Now, one thing that's different here, our move and slide doesn't require us to pass in the velocity, and that move and slide method, it takes into account the velocity as well as the delta. And the move and collide does not know how to handle that. We have to tell it how to handle it. So we are going to pass in the velocity and multiply it by the delta so that we only get the amount of velocity that's applicable during the current physics tick, if that makes sense, right? This is the duration, and this is the velocity to apply over that duration, okay? So we do need to provide that here. This technically, I think, should work. Let's go ahead and just run this. We should see our fireball fall because we have gravity. Yeah, you see how it's falling? And it's falling kind of slowly because we've got a low multiplier on it. If we look at our fireball, it's at 0.1. So if we were to reset this, or if I were to set this to, like, let's set it to 2. Let's run again. Then it should fall very quickly. Boink. Okay, and you'll see it's not destroying yet when it hits the ground, but it will after the 5-second timer. Okay, so how do we make it destroy when it hits the ground? Now, one thing that's different about move and collide and move and slide, or another thing that's different, is that this, as we read, it returns collision. Okay, so you can see it's not a like return of void. It means that this actually returns some information sometimes. Okay, and it returns this kinematic collision 2D. So it'll tell us if it collides. And in order to access that, we can store the result of this method as a variable. So we'll say VAR COL, VOL. So it's a collision. And this is of type kinematic. How do I spell this? Kinematic collision 2D. There we go. Equals this. So we're defining a new value or variant based on the result of this move and collide. So then it's pretty simple. What we can do, if there's no collision, this will be null. So collision is going to be null most frames, but when there is a collision, it will have something in there. And we can do stuff with that information, but really all we want to know is if there was a collision or not. And if there was a collision, if collision, right, which is the same as saying if collision does not equal null. Okay, I'm just going to go ahead and leave it if collision. We're not going to care what it contains. Then we're going to call our destroy function, just like we do when this collides with the player, when the hazard area hits him. Okay, so there we go. That's going to be our entire physics process. It could be 2 lines if we weren't doing this bit here, and we were using move and slide. But because of this, now what will happen is when this fireball hits the ground, it will destroy itself. So let's go ahead and test that. Boom. Okay, see that? It's just dropping from his mouth, hitting the ground and destroying itself. Okay, so we've solved this problem. You can go ahead and test out and try to do using the hazard area. Just trust me otherwise. This is a nice way to handle this. Okay, so our physics process is done. And now I want to move on to the start function, because the start function is what we're going to use to calculate all of our velocity. And before we get into the code, I want to remind you that this is being called, where do we have our, let's go to our projectile spawner. Whenever we fire a projectile, the last thing we do is we start it. If it's of type projectile, then we call the start function and we give it the target position, whatever we're trying to shoot. Okay. So this is usually the player. We're using fire at player in the case of our gargoyle here. In fact, let me just show you real quick, full round. This gargoyle has an attack animation, and the attack animation I have, I'm calling functions on the projectile spawner. So you can see right here when he should be shooting a fireball, I call fire at player. And there we go. Pretty easy peasy, right? So then all that happens, and then really what happens from that point forward is once the projectile is created and is given a target position, it decides where to go, what its velocity should be, and that's what this start function is responsible for calculating. Okay, first things first, you can see in our start, we're expecting the target position, and I just showed how we're passing that in our projectile spawner. So let's go ahead and store that. We do have a local variable in this script, wherever it is, target position. So let's go ahead and record that variable there. So we'll say target position equals underscore target position. Now that's set. Then we can refer back to it at any time. Now, a quick side note, this is going to record the target position at the time the projectile is fired. And so as the player is moving, it's still going to fire to the original position the player was at when the projectile started. If you want it to be like a homing missile, then you could update target position maybe in the physics process or something like that. But then you'd have to pass a node and track that node I'm not going to be doing that, but that's just a little side note for those of you who want to take this further. Now, what we need to do is let's first just set our velocity, our x velocity, because this is going to allow the fireball to move forward in a direction, right? So I'm going to just say velocity.x equals, and I'm going to use sine here, because what we need to do is we need to get the direction to our target position. And I'm going to use this functionality. I'm going to write it in a specific way because it's going to lend itself to how we're going to write code as we evolve this to be more dynamic when we're calculating the trajectory instead of a straight line. Okay, so what we're going to do is we're going to get the sine of this value right here, our target's x position minus our global x position. So we're going to look at, that's going to give us a distance, but what we want is we want to convert this to either 1 or -1, because really our velocity x is going to be just positive or negative, and then multiply this by our move speed. Okay, so we have move speed, which by default is set to 150. So now if I run this, we should see that the fireball is going to move. Yeah, and actually, hold on. That's good. Let's go back to my fireball real quick. I'm going to reset this gravity strength. It's on 0. And I'm going to turn on horizontal only, even though that doesn't do anything yet. But by virtue of gravity at 0, it should just fly in a straight line and not fall anymore. There we go. So you can see that the fireball is flying in a straight line. And it will eventually hit the wall or just blow up. I don't know which. Yeah, it just blows up. It's hit in 5 seconds first. Okay. So this works. We're assigning our x velocity. I want to do one other thing before we evolve this too much further. And that is I want to make sure we're handling our sprite and our audio playback. So really this code right up here, I almost don't need this because that should get called on start, but in the case where start doesn't happen, I'm just going to ignore it. I'm going to leave it. That's maybe some good code cleanup though for later, but I'm going to just check if sprite and velocity.x is less than 0. Okay. Then I'm going to flip it because otherwise it should already be facing the correct direction. And so, you know what? I said I'm not going to clean that up. I'm going to clean that up after this. So I'm going to say flip h equals true. Now this assumes that your sprite is facing to the right by default. And then if it's moving left, you want to flip it. Okay. If your sprites are facing left, then you get to adjust this logic. Okay. Now I'm going to come up here. Really, I don't think we need these 2 lines of code now that I think about it. So we'll just go like that. Okay. And in order to test this, let's go ahead and go into our playground. And I'm going to duplicate my gargoyle. You can see he's got this area. The player has to be within that area for him to shoot. I'm going to duplicate him. And I'm going to move him way over here. And I'm going to have him face left, which will flip this when we run the game. You'll see that. Okay, he's firing. Now this guy should fire to the left. And you can see the fireball is facing left. Okay, very good. So back to our projectile script, start function, we're flipping it. We do also have an audio stream that we want to play back when he shoots the fireball. So let's play that as well. So we'll just say, what did we call that? It's if spawn audio. I think spawn audio is what I called that variable. Yeah, there we go. If we have a spawn audio, then we'll go ahead and play that back. And that's just using the same play spatial sound. So we'll play the spawn audio at this node's global position. And one more test to make sure it's playing that. Nice. Okay, so he's got a little sound effect when he shoots. Very good. Okay, so this is just kind of like some of the game juice aesthetic bits of this. Not super important. Okay, so we've got it flying in a straight line. We also have gravity applying itself. And so what I want to do is just to kind of help prove this concept, I'm going to turn horizontal off and I'm going to set gravity strength to 0.1 and just run this again so we can see what's happening. Okay, so now it's falling very slowly. It's got 1/10 of the gravity that a normal object would have in our world. Okay. because that's a good slow fall speed. What that means is this fireball is not going to move up or down very quickly if we want it to calculate a trajectory. Okay, if we were to set it to 1, right, then it's going to have a regular amount of gravity, which means it's going to shoot up into the air quite a bit more and fall quite a bit faster. And maybe we'll leave it at 1 right now. But let's do this. What we need to do in order to be able to calculate all of this is we need to calculate some distances to begin with, right? Because we need to know, in order to know how much vertical velocity to apply, if we're not using horizontal only, if we're going to give it a trajectory, we need to know how far it's going to travel, both in the X direction and in the Y direction, in order to hit its target. Okay? And we also need to kind of know what the gravity is, because the gravity is essentially our velocity on that Y-axis, and we're assigning the X velocity right here, so we can just use that, right? So let's just set up a couple variables. I'm going to say G for gravity. This is a float, and this will equal, we're going to just calculate our gravity multiplied by our gravity strength. Okay, so this is going to tell this, we're just going to use this G variable in this function to help us do some math. We're also going to want the two distances I mentioned. So we're going to have a distance on the X-axis. And what we'll do is, this is the distance in the X-axis right here. So I'm going to cut that out and I'm going to paste it. And then we can just put this dx right in here where we pulled that out of. I'm going to copy this and change all the x's in here to y's. And this is going to give us our distance y. Okay, so what distance x tells us is the pixels, positive or negative, from where this fireball starts to the target, in this case, our player. Same with the y. So this is going to tell us is the player above or below the starting position of this fireball, okay? We can go ahead and maintain this bit of code here. Okay, so the next step really is that we need to calculate the time, like a duration, that the amount of time that it takes for our projectile while it's traveling across the x-axis to go from its start location to the target location, which in this case is the player's global position. Okay, so we're going to calculate the time, right? Because it's moving at a move speed. Let's just revisit this fireball real quick. It's got a move speed of 150. So if the player were 300 pixels away from where it started and it's moving at a rate of 150 pixels per second, then the flight time is 2 seconds. Now that information, that time, is going to be critical for us being able to calculate how much vertical velocity we want to add, okay? So let's go ahead and calculate this time. I'm going to call this variable time. And I actually had to record this section because I got it wrong accidentally. It's very easy to get these math things wrong, just one wrong symbol. So we want our distance in the x direction, but we want the absolute value, so it's always positive, right? Because we don't care if it's left or right. We just want the total magnitude of that distance. And then we're going to divide this. Now, see, the error I made before is I multiplied. We got to divide this by the move speed, I think should work. Okay. Now, if you're doing anything where you're calculating the move speed, etc., you might want to actually take the absolute value of your x velocity. If for any reason that might be different. In our case, because we're getting the sign of the distance, that's going to be 1 or -1, and we're multiplying it by the move speed, there's no need for us to do that. But if for some reason your math is different, note that you may need to change this here. Okay, so this is going to give us the time and duration. We can go ahead and print this out. So right now, every time a fireball fires, we should get a little output. Okay, you can see 1.42 seconds. Now, if I move closer, then the number is lower, 0.813. And if I move further away, then we should get a higher number. I should still be within range. It'll try and shoot me. 2 seconds, okay? So we're calculating a time for that to travel. Like I said, that's critical for getting the vertical velocity, because now what we want to do is we want to give it enough upward velocity that when we account for gravity, it will go up and fall down and land vertically right where the player or the target is at the time we fired the projectile. Now that part is critical too. If we move the fireball is going to aim at the location the player was at the time it fired. If you want that to be different, you can change it. I don't really want to calculate this velocity later, but if you wanted like a homing effect, then maybe you have to recalculate the velocity in your physics process. Okay, so here's what we're going to do. We just need a couple bits of code down here. Essentially, what we're going to do is first I want to just check if we're horizontal only, then we're not going to do anything extra. We're just going to set our gravity strength to 0. Because in this situation, right, we don't want the projectile to fall, to be affected by gravity. Else, if it's not horizontal only, then what we'll do is we will calculate this velocity. I'm going to go ahead and do pass here right now. So what we should see is, even if I have gravity strength, let's set this to 1. Save this. And I'm going to run the game. Right now, horizontal only is off. So we should see, yeah, it's got gravity, right? Now let's go ahead and turn horizontal only on and run it again. We should see that the fireball goes straight line, okay? So that checkbox, that's what that's doing. And now some of you may look at this and say, some of this stuff should only happen in this branch, and you could change it. I'm not going to, because I just don't think it's that important. We're only calling this function once the node is instantiated, so I'm not too worried about it. But if you're doing anything on a regular basis, then yeah, you might want to change that to optimize it. Okay, so what we'll do in here, like I said, is we just need to calculate the y velocity. So what we're going to do in here is I'm going to give you an equation that will compute the upward speed that the projectile needs in order to, after gravity acts upon it, land exactly at the target position, okay? And this is what this will look like. We're going to do some things in here. An order of operations is important, but we're going to take our distance, y, that we calculated up above, and then we're going to subtract from it the effects of the force of gravity. And the way that we're going to calculate that is we're going to take half, 0.5, times, and then we're going to take the gravity that we calculated up here. Okay, so this is our gravity multiplied by our gravity strength. So this is going to be adjusted for that gravity strength. And then we need to multiply it by time squared, or just time times time, like so. And then outside here, we can divide it by time. Okay, so this part happens because of order of operations. This happens first, then we subtract that from our y distance, and then we divide it by our time. What we're doing here is we're rearranging the kinematic equation to solve for the initial velocity, okay? And so I'm not like a great physicist or mathematician, and so I'm not going to try and explain it any better than that. But, you know, for those of you who know, maybe you could drop a comment and help us out. Otherwise, go ahead and do some research on your own if you want to dig into it. But there we go. This is how we solve for the y launch velocity. It's actually really simple, right? That it's just one line of code. So now let's see, let's go ahead and save this. And I'm going to just double check this. I think this looks good. And I'm hoping I've got horizontal only off. Right now I've got a gravity strength of 1. So let's see what happens. It might look a little goofy. Boom. Okay, you see that fireball got launched pretty high, right? I'm going to go over here. Now, this is working. This would be really good for maybe lobbing something like a bomb or something like that. Okay, and this is, I think, the beauty of this approach. And of course, you can change it, but this hopefully illustrates some of the things you can do. Let's go ahead and change the gravity strength to 0.1. So this is going to simulate something that's like an arrow that's flying through the air, but is less affected by gravity because it's got fletches or something like that, right? So we're saying that the effect of the gravity on this projectile is 1/10 of a normal gravity. So now if we run this, you're going to see a much more pleasing effect on, oops, I don't know if I saved that. So I still have my cursor in there. Let's go ahead and tab out, save, and run again. There we go. You see how that has a nice gradual effect? And it's going to land right on the player every time. And it barely goes up. Okay, I'm going to jump up here. It should still fly up and hit him. Perfect. Okay. So that's really all it takes to do this. Now, as mentioned earlier in my video, there are some ways that you could adjust this. So for example, you could change your equation to do something where it kind of calculates like a maximum amount of height, and if it exceeds that, then you do a different kind of formula, or maybe you always use the formula that gives you the same amount of height on your launch. But what's nice about this one is if I'm down here below, it's not going to go up. It's just going to go down. And if I'm up here, I don't know if I could time that just right. You see, it's still gonna, it's just gonna go up. So that's really good. And we can kind of play around with this, you know. I'm gonna set this to 0.5 just for fun, and we'll just test this out while I talk. And actually, I should change the move speed maybe. Let's increase it to 250. So this is a faster projectile. Boom. And that works pretty good too. See how that looks? It looks pretty nice, I'd say. He's not gonna shoot up here. I'm outside of his attack zone. Up here should work. It might be hitting up here. Yeah, it just barely did. There we have it. So thank you for watching. If you've got questions, go ahead and drop them below. And I just created this video because I wanted to get something out there while I'm in the background working on chapter 6, which is focused on our boss battles. I do have a little bit of work to do on it, and unfortunately for you guys, and even for myself in some ways, I've been on vacation a lot. I was out in the mountains last week. I lost a whole week to that, plus you know, just taking care of family and work and other things. So I am working on the boss chapter, and it will be the next thing I get out there. I may do one other small video like this where I address a little feature that relates specifically to our enemies. But I hope you guys have enjoyed this. If you're new to the channel and you want to see what's going on, go ahead and subscribe so you can see what's next, or find the beginning of this series if you want to start from ground zero and build the whole project with us. And as always, we'll see you next time.